So first thing I'm gonna do is write product equals going to be the sum 2x2 box. Okay, circle my like terms. All right. Any questions about number 23? We good on 23? Okay, now for 24, I'm going to take the r minus 6 squared and rewrite it to r minus 6, r minus 6. Two by two box. Be really careful in this box that you have the negative times the negative is a positive 36. R squared minus 12r plus 36. And again, don't worry, you guys, I'm gonna stamp again this period. I just wanted to get the warm-ups out of the way because of the flipping. Okay, you guys, so the first thing I want to tell you is the name of these problems. So you're going to see, I don't know if you guys saw, I posted the test topics for next week for your chapter 2 test. And there's something called same base exponential. I want to take that name, take a second, and make sure that you understand that that's what this is. So think about the word same base. What's the base of an exponent? Like the big number, right? Okay, so same base exponentials. Does that make sense? You really like the whole goal of these is to get the same base. So on number 132A and 133A, those are the easy baby problems because they already have the same base. And problems like B in both of these are harder because they do not start with the same base. And so you actually have to make them have the same base. Interestingly enough, here's my warm-ups for Math 3 this chapter. Those problems are all same base exponentials. So just want you to know this this is a pre-Math 3 style problem. I don't know how much of Math 2 you will touch in this, but I do know in Math 3 we use it. So let's start with these two baby ones because they're super easy and they already have the same base. Because they have the same base, you can cancel it out and equal the exponents. I also have to warn you that these notoriously have weird answers. So if you get a weird answer, we're not going to in this problem here, but if you do, it's totally okay. Okay, now we're going to skip down to here. Number 133A. My first question is, do they have the same base? Yes. Okay, that's great news. That means all we have to do is equal the exponents and solve. Okay, so if I was playing a video game, that would have been level 1. Okay, now we're going to get into the harder style problems. So these ones are unfortunate because they don't already have the same base. So what I like to do is I will take the larger base and write it over here. So I'm just looking at the bases. I'm just looking at 4 and 16. And I take the larger of the two and write it over here. And I'm going to make a factor tree. 16 is 4 times 4. Is that okay with everybody? You're good with that? Okay, so I'm going to rewrite 16 as 4 squared. Okay, now watch very carefully. This side is going to stay 4 to the 4. I'm not doing anything to that side, stays the same. But in the spot where the 16 is, I'm going to change that to be 4 squared. So think of these like little puzzles. How can I make it have the same base? I have to force it to have the same base. And then don't forget the little x that was there in the beginning of the problem. Okay, now remember your exponent rules. These two will multiply. So you have 4 to the 4 equals 4 to the 2x. Okay, now, do I have the same base? Yep. Great news. They cancel out. Mrs. Talbot, I'd just like to complain that you made this big deal out of how they all get weird answers and we haven't gotten a weird answer yet. Yeah, I know it's coming. Okay, now take a look at B. Does anyone have any idea of how I could make these have the same base? Okay, exactly. So take the 9. It's the bigger of the two bases. Put it over here. 9 is 3 times 3. That's great because that's the base of the other one. Perfect. So 9 is 3 squared. Okay, 3 to the 5th. I'm just going to leave that the way it was because it already has a base of 3. And 9, I'm going to change to 3 squared. And then I can't forget the 2x that was there in the original problem. Okay. Now multiply those. Get 4x. Five over 4 equals x, which isn't even really that weird, but I did a quiz, a math 3 quiz, with one of these like 2 weeks ago, and their final answers were like 20 over 11 and stuff like really, really weird. So if you get something weird, it's totally fine. Okay. Okay. C. What do I do for C? Tell me what to do. I'm lost. Yes. Beautiful. And I love how you said bases instead of threes because there's a extra rogue 3 in there that could have been confusing for me. Woohoo. Okay. Last one. E. Okay. Here's your baby question. First baby question. Do they have the same base right now? No. Which of the bases is bigger? 8. Okay, so I made a factor tree to make it into base 2. Okay, so this is a little weird because that's 70. So the 8 becomes 2 to the third itself, just the 8. And then you got to put the 70 on there because he still lives there. Okay, then you multiply those. 210, right? Okay, now I have a mixed review problem for you. Number 134 in the book is a bunch of different types of equations to solve. I want you guys to do them on whiteboards and not in your notebook, but please do not put your notebook or your packet away. What I would love is for you to go in your notebook, find the homework 114 to 119. And then put your packet in that page in your notebook. And then close your notebook and switch it over for me to see. So find the homework 114 to 119, put your packet in there, close your notebook, and just scooch it over to the side. Okay. If you don't have that, just open your packet to something I need to stamp, or I don't know. I'm just gonna come stamp while you're working on whiteboards. Okay, so we're gonna do this in a very specific way. There's 8 problems, 8 different equations to solve. What you're gonna do is bring somebody up here and run them. You're not all by yourself. You're gonna send a representative up to get a whiteboard and 4 markers and an eraser cloth thing. You guys back there are probably gonna have to use the eraser cloth thing that's hanging up, because I think I only have, I don't know how many I have anymore. And you're each going to write the problem down in your corner of the whiteboard. You guys remember when we were doing this with the puzzle? Okay, so you're going to write the problem down. Everyone's gonna write down the same problem. So you're not gonna have everybody working on different ones. Everyone's gonna work on A. Everyone's gonna work on B. Everyone's gonna work on C. So you all get the same answer. Okay, then what I want you to do is I want you to send a representative over when your group is ready to check the tiny answer key I have created. Teeny, tiny, teeny answer key to see if you're correct and you can move on. Now, I'll probably control the answer key after I'm done stamping, but for now, you can just come over and check it. And then if you're correct, move on to the next one. You have like almost an hour to do this, except for the last 15 minutes. I don't know if you guys noticed what tonight's homework is. Did you see it? Okay, I'm thinking if we're smart, we do a couple of those to remind you how to do it. Like, so I can do a couple of those for you to get you going on your homework, but we'll see how long this takes everybody. But I feel like if we're smart, we would do a few of or a couple of those before you go. Okay, here are the problems. You've got all different types of mixed equations to solve. Some of them require boxes. Some require fraction busting. Some require the thing we just did. Okay, do you understand the instructions? Everybody's got the instructions? Okay, this is where you get to argue and erase with the whiteboards and it'll be fun. Arguing's fun. Okay, go ahead, get your stuff. I'm gonna come stamp everything else while you're working on these.
And here's Swedish. Yeah, the X school, yeah, the next word was square. No, it's not. How is this going? Yeah. Oh, I just. Oh. Okay. So there's to be around this, the gravy, okay, so. Oh, yeah. And then you have Yes, I think it's this one. This one is the sorry, my girl. It's usually then the next one was 15 people. No. That's also Yeah. Oh, yeah, yeah. I'm so sick of them. Oh, maybe, And I know there is. Why are you guys missing it? Okay. Oh, yeah, definitely. Okay. Oh, yeah. Oh, I brought it. No, mine was right. Hey. Oh, wait, that. Oh. That's good. It's supposed to be. What? No. No, how do you not so low? So.
Like, no, I know. Oh, yeah. I just thought I would ask you more. I also have conflict. I don't bring home. Yeah, tell us, I know.
To have it nice.
I mean, you're supposed to be working with degrees. You're supposed to figure out the struggle.
Oh, that's because that's multipliers and by eggs. And then.
The common denominator is 9.
Why you don't go to that?
Or you could get it to be a proportion and cross it multiply, you know, but if you multiply all the text by 9a, you come to the fraction. You just have to notice that a is also on the bottom, so it's part of the common denominator.
No, it's not working.
If you have one that's not working, it's through doing. Would not throw away. All right. Yep. You mean outside? Yeah, of course. No, I mean like, not having that's the teacher. Like, I just wanted to tell you I can't change, but I gotta make that over. What you, you're. Oh.
Yeah, I got it.
I'm trying to think of that.
How do you get it? Because when you correct the. Oh, right, you have
Oh, that's right. How did you know? Cause you're on that type of problem.
Basically, it's called, I was called. Oh, you didn't?
Three, good. That's not what you want to do, right? And then you have the fraction of your description. That's fine. Is there any?
I think.
I mean, what it has. Okay. Oh, he got it. Sure, it's a- Okay. Okay.
I'm gonna start working on number 1 up here. So follow along if you like. If you don't want to, totally fine too. Just don't talk while I'm doing it. Okay, so I'm gonna start with what they gave me. 3.10 kilometers. And I know that I need to convert from kilometers, so I'm gonna put kilometers on the bottom. I have to do that because I need to cancel out the units of kilometers. And I want to go to feet. So I have 2 options, kilometers to miles or kilometers to meters. Payson, it's 1. Did you get 1? Mhm. Okay, and since you want to go to feet, you want to put miles on the top because I have another conversion right here from miles to feet. So this box says 1 kilometer is 0.621 miles. And then I cross out the kilometers. Okay, and then I know miles needs to go on the bottom because I need to cross it out. So I'm going to go to this box. 1 mile is 5,280 feet. And now my final units are feet. Okay. And remember, we multiply the things on the top and divide the things on the bottom. So 3.10 times 0.621 times 5,280. And I could do divided by 1, divided by 1. It's not going to help. It's not going to change my answer, but I could if it made me feel better. 10,164.5 feet. Okay. Part 2. Determine the milliliters of paint in a 5.0 gallon bucket. I write 5.0 gallons times line. And I need to make sure that gallons are in the bottom. Okay, gallons is over here. 1 gallon is 3.79 liters. Okay, and then I have to put liters on the bottom. 1 liter is 1,000 milliliters. Multiply across the top. 18,950 milliliters. Okay, 3.50 days. Put days in the bottom. And there's two options for days in my box up here, my conversion factors box. One day is 24 hours and 1 year is 365 days. Which one of those do I want to use if I want to go to minutes? Hours, right? Okay. So I want to do 1 day is 24 hours. I need hours to be on the bottom so I can cancel it out. 1 hour is 60 minutes. Multiply the things on the top. Okay, so I know that I have to start with this. I want to go to ounces. I guess I have to use this one. 1 kilogram is 2.2 pounds. Is that what you guys did? Yeah. And then did the pound to ounces one? My question is, why is the symbol for pounds LBS? No idea. Did you guys know that the symbol for pounds was LB? It's so weird. And ounces is OZ. Like, what the heck? I don't know. I was not around when they came up with these. The whole first page kind of feels like they're trying to establish a pattern, which is good. I like that.